So in the last couple days, we have talked about solving systems of equations, and today we are going to talk about some special cases of these. Now, most systems of equations that you come across will have one solution, and that is if you were to graph it where the lines intersect. It's that one xy ordered pair that satisfies both equations. However, sometimes either they won't just intersect in one spot, or they will not intersect at all. So let's take a look at what this actually would look like on a graph, and then what that looks like in equations. So we're actually going to skip down here to the graph. If you think about being able to have either there's one solution, some of them have infinitely many solutions, and some of them have no solution. If there's infinitely many solutions, that means that the two equations in the system of equations are actually really the same equation. Maybe they look different. Maybe they're, one of them is all times by 4, but if you were to divide it all by 4, it would be right back to where you started. It's the same as the other one. So they could be like a multiple of each other. Maybe they're rearranged differently, but if you simplify both of them completely down, they'll both end up actually the same equation. So let's look at some examples of that. If you skip down here, if this is one line that represents one equation in the system, and if it has infinitely many solutions, that means it intersects everywhere because the intersection point is the solution. So if it's really the same line, those are actually intersecting everywhere. So I'm just going to make that really thick so it looks like there's two on top of each other there. So really these lines intersect everywhere because they're the same line. Over here, let's say we have this. There's one line. Here's the other one. Right on top of it. So whenever there's the two lines that are right on top of each other, that means they're actually intersecting infinitely many times. So there are infinitely many solutions. Now that could be obvious. People make these brackets often so that you know that these two equations that you write right here form a system. They're like stuck together. So I'm just going to do that. So this is an example, and it could be obvious. It could be like this. Those are very clearly the same equation. It could be a little bit less obvious. You could have y equals 3x plus 1, and you could have y minus 1 equals 3x. Even though they look a little bit different, they're actually the same, because if you were to add 1 to both sides, it would turn into that. So sometimes it can be a little bit tricky. You might have an equation that looks like this. Maybe you have 2x minus 3y equals 7 in standard form. And then another one is 4x minus 6y equals 14. Those are actually the same equation because you can do something on both sides of the equation and it doesn't change its value. It's still the same equation. For example, up here we could add 1 to both sides. And then that turns into y equals 3x plus 1. Well, down here, what if we divide everything by 2 on both sides? Then that turns into 4 divided by 2 is 2x. 6 divided by 2 would be minus 3y equals 14 divided by 2 is 7. The same. So sometimes it's obvious when two equations are the same. Sometimes it's not. But if you could simplify them or rearrange them or multiply or add or divide or subtract both sides by something to make them the same, then they really are the same line. And so there are infinitely many solutions. The other situation is if there's no solution. Let's look at some graphs. Because the solution happens when the two graphs intersect, if the two graphs never intersect, that means there's no solution. And if they never intersect, that means the lines must be parallel. So whenever you have a situation with two parallel lines, that means there is no solution there. Or here, maybe we can do that. and that one. Again, no solution because those two lines are parallel. So they're never going to touch. Now what that looks like here in equation form is whenever you have two lines that have the same slope. Because if two lines are parallel, that means they must have the same slope. So you could have y equals, we'll say 2x. Let's do this right here. The slope of that is actually about 1x. So we're just going to say x because you go up 1 over 1, up 1 over 1. Okay? And then here the y-intercept is at a positive 3. For my other line, it also has a slope of x and a y-intercept of negative 1. These two lines have the same slope, 1. Never mind my scribble there. They have the same slope, but they're not the same line. If they were the same line, like if these are both a plus 3, then they'd be the same lines. They'd have infinitely many solutions. They'd be on top of each other. But they're not. They have the same slope, so they're parallel. They're going in the same direction, but they're in different spots. One of them starts at a positive 3 on the y-axis. The other one starts at a negative 1 on the y-axis. Here's another example. Y equals 2x, minus 6. Y equals 2x plus 5. Again, same slope, so you know they're parallel, which means they're never going to touch, which means they're going to have no solution, but different lines. One goes through negative 6 on the y-axis, one goes through a positive 5 on the y-axis. Because the solution happens when the two lines intersect, so if they never intersect, because they're parallel, that means they're never going to have a solution. There is no xy ordered pair that's on both lines. Okay, so that is some special cases of systems of equations. Most systems that you come across are probably going to have one solution, one ordered pair where they cross. Here's two special cases though. Sometimes they might have infinitely many solutions if they're actually the same line, but being tricky. Sometimes they're going to have no solution if they're actually parallel lines. And that's all.